Principles of wireless optical communication. Wireless optical communication is a method of transmitting data wirelessly using light as the medium. This technology is becoming increasingly popular due to its high bandwidth, immunity to electromagnetic interference, and low cost. In this article, we will discuss the principles of wireless optical communication, including how it works, the different types of wireless optical communication, and its applications. How wireless optical communication works. Wireless optical communication uses light waves to transfer data from one device to another. This is done using a transmitter and a receiver. The transmitter converts electrical signals into light waves and sends them towards the receiver. The receiver, in turn, converts the light waves into electrical signals that can be processed by a computer or other device. The transmission of light waves occurs through the use of electromagnetic radiation. Electromagnetic radiation is a form of energy that is transmitted through space at the speed of light. It is composed of two components, an electric field and a magnetic field. These two components are perpendicular to each other and to the direction of propagation. In wireless optical communication, light waves are used as the medium for transmitting data. These waves travel through the air or through a special transparent medium, such as a fiber optic cable. The speed of light in air is approximately 299,792,458 meters per second. This speed is significantly faster than the speed of electrical signals transmitted through wires. Types of wireless optical communication. There are several types of wireless optical communication, including infrared communication, visible light communication, and ultraviolet communication. Infrared communication uses infrared radiation to transmit data wirelessly. This type of communication is commonly used in remote controls, where the user directs a beam of infrared radiation towards the device they wish to control. Visible light communication, also known as Wi-Fi, uses visible light to transmit data. This type of communication is becoming increasingly popular, as it offers high-speed data transfer rates and is immune to electromagnetic interference. Wi-Fi is used in a variety of applications, including indoor positioning systems, medical monitoring, and automotive applications. Ultraviolet communication uses ultraviolet radiation to transmit data wirelessly. This type of communication is commonly used in underwater communication, as ultraviolet radiation has a short wavelength. GTH that is capable of penetrating water. This makes it ideal for transmitting data in underwater environments. Applications of wireless optical communication. Wireless optical communication has many applications, including in telecommunications, medical monitoring, and automotive applications. In telecommunications, wireless optical communication is used to transmit data over short distances. This is done using infrared or visible light communication, as they offer high-speed data transfer rates and are immune to electromagnetic interference. In medical monitoring, wireless optical communication is used to transmit data from medical devices to a computer or other device. This is done using infrared or visible light communication, as they offer high bandwidth and are immune to electromagnetic interference. This technology is particularly useful for monitoring patients with chronic conditions, as it allows doctors to monitor their condition remotely. In automotive applications, wireless optical communication is used to transmit data between vehicles and infrastructure. This is done using visible light communication, as it offers high-speed data to transfer rates and is immune to electromagnetic interference. This technology is particularly useful for autonomous vehicles, as it allows them to communicate with other vehicles and infrastructure in real time. Advantages and disadvantages of wireless optical communication. Wireless optical communication offers several advantages over traditional wired communication. One of the main advantages is its high bandwidth, which allows for the transfer of large amounts of data quickly and efficiently. It is also immune to electromagnetic interference, which can be a problem in wired communication systems. Another advantage of wireless optical communication is its low cost. This technology is relatively inexpensive to implement, as it does not require the use of expensive cables or